Hello, my name is Julie Finlandia and I'm going to talk to you today about physical cryptography and I'm going to focus on Giles Millionaire's problem. So, what is physical cryptography? Physical cryptography is a cryptographic tool that allows you to encrypt, decrypt, and exchange information between multiple people, multiple parties, using the physical system's properties without implementing one-way functions. So what I mean by that is that you can take the physical item of communication and you can use the physical properties of this item without having to implement one-way functions. And by one-way functions, I mean those functions that are really easy to do, really easy to implement, but it's really hard to take out the invert of, or the inverse. It's really hard to find their inverse. So I'm gonna focus on Giles Millionaire's problem now. Giles Millionaire problem was a problem proposed by a computer scientist and computational theorist Andrew Young. It's a secure multi-party computation problem that whose basis or whose main idea is to prove or to or to show whether the inequality a greater than or equals to b is true or false without revealing the values of true values of a and b. So in terms of millionaires section of the millionaires problem, it's basically two people, rich people, wanting to know which one of them is wealthier. So I did an example with two people that we know very well, two characters that we know very well. Who is wealthiest? Scrooge McDuck or Mr. Burns? So Giles Millionaire problem. So the way Giles Millionaire problem works is it people there's two people, people A and people B, person A and person B. I'm sorry. And the way it works is person A would need to make um, I guess you could call it saves, boxes, spaces, private spaces. Uh, for the wealth, the age, whatever it is that they're trying to compare. So you would, person A would set up those different boxes, different spaces, private spaces with all labeled out. Um, and person B will come in. Person B would put in notes inside these safes, inside these boxes, inside these spaces, and they will go all according to the wealth of the person. So, for example, let's follow our example. So, for our example, let's assume that A's and B's network is between 10 billion and 50 billion. So, for the sake of the example, let's assume that Scrooge is A and Mr. Burns is B. So, we would like to know they would like to know who is the wealthiest of them without sharing their individual net worth. So, for the sake of the problem, let's assume that A's and B's net worth is between 10 billion and 50 billion dollars. Um, so, in order for them to find out who is the wealthiest, they will need to use Zhao's protocol. That goes as follows. So, to find out who the wealthiest is, person A will set 5 saves, each level by tens, as follows: 10, 20, 30, 40, 50. In order for this to work, both people would have to have the keys to all the safes. Um, so the way it works is as follows. So person A will take all the keys from the safes without B knowing, right? And she would take her set of keys. I mean, he will take his set of keys for the safes, and he will dispose of all of those keys except for the one that is labeled with his net worth value. For the sake of the example, let's assume that it is 40 billion without person B knowing. Person B will then place a note, yes or no, within each of the individual safes by opening them with the keys, with his set of keys, and without person A knowing. Next, person A will open the safe that corresponds to his key, and he will read the note that it is within the safe. Then, if the note says yes, then it means that person's B network value is less than or equal to person A. If the note says no, then person A's value is greater than person B. I mean, B's value is greater than person A. So for the sake of our example, person B has placed a just node inside A's safe, meaning Mr. Burns placed a just node in Mr. Scrooge's safe, which means that the Scrooge is wealthier than Mr. So now I'm gonna focus on a list of solutions for Zhao's millionaire problems. Now there's many solutions to Zhao's millionaire problems, but I will only focus on four. So there's the elevator solution, there's the racetrack solution, the communicating vessel solution, the the laboratory solution, the solitaire solution, the password solution, the public key encryption solution, the robo solution. But I would only focus on four. I'm only going to focus on four: the elevator solution, the racetrack solution, the communicating vessels solution, and last but not least, the public key encryption solution. The elevator solution. The elevator solution is known and is defined as logistically one of the simplest solutions to Child's millionaire's problem, and you will see why. So the way the elevator solution works is there's two people, person A and person B, and person A and person B will go into an elevator that is n floors tall. Person A will go into the elevator, and person A will get off at the floor corresponding to his wealth. Then person B will do the same thing, get on the elevator, get off at the floor that corresponds to his wealth. Once they're both in their corresponding floors, person B will take the elevator and will go down the elevator, will go down to ground level, and as it goes down, he would stop in every single floor until he reaches ground level. Once he reaches ground level, he's going to call person A to see if person A saw him stop at any of the floors, because while he's doing this, while person B is doing this, person A is looking to see if person B stopped at his floor. And if he did, person A will let him know. If it if if he stopped in person A's floor, it means that person B's wealth is greater than or equal to person A's wealth. Otherwise, person A's wealth is greater than person B's wealth. So now let's grab our example with the Scrooge and Mr. Burns, and let's follow it through. So suppose there's a building, there's an elevator building with that is n floors tall. So now Scrooge will take the elevator and go to the floor with his network value on it, Scrooge private space. And Mr. Burns will do the same thing. He will take the elevator and go to the floor with his network value. Now Mr. Burns will then ride the elevator and stop in every floor until he reaches ground level. Once he is in ground level, he will ask Scrooge to see if Scrooge saw him stop at Scrooge's level. Because while he's going down the elevator, Mr. Scrooge will be looking to see if Mr. Burns stops at his level, at his floor. So once in ground floor, Mr. Burns will ask Scrooge if he saw the elevator stop at Mr. Scrooge's level. If the elevator stopped in the Scrooge's floor, then Mr. Burns' wealth is greater than or equal to Mr. Scrooge's wealth. Otherwise, Scrooge is the wealthiest. So for the sake of our example, Mr. Burns did not stop in Scrooge's floor. So they got on the elevator. Mr. Burns went down, did not stop in Mr. Scrooge's floor. Therefore, Scrooge McDuck is wealthier than Mr. Burns. Next, let's talk about the racetrack solution. So the way the racetrack solution works is two people would race against each other on a track that is n feet and meters and units long. They would start on opposite sides and they would try to reach the midpoint of the racetrack. Whoever reaches that midpoint will leave a mark, and then it would finish, and then that person would finish the race. So whoever reaches the midpoint first will leave a mark and finish the race, and the next person will reach the midpoint and will finish the race. Now by the end of the race, both sides know who was fastest and who was slower, because once the first person puts the mark in the midpoint area, this person already knows that he was faster than the other one, and therefore when the other one reaches that midpoint, this other person would know that he was slower than his rival. So for the sake of our example, let's just assume that the speed at which they were competing, racing, are the wealths. So whoever got there faster is wealthier than whoever got there later. And in no moment there was information shared between them. There was no sharing of the speeds. There was no sharing of wealth. Nothing. Now we're doing the communicating vessels. So now we're gonna focus on the communicating vessels. The communicating vessel solution works as follows. There's two vessels, and they're situated in a private space that corresponds to the two people. And these vessels are connected together by via a pipe underwater. Now these two vessels are filled with water. Now person A is pumping water at a speed of 8 gallons per second. Person B is pumping water at a speed of B gallons per second. So in this solution, let me reverse. So how does that help? How is that relevant to this solution? Well, because in this solution, you're looking at the level of the water. You're looking at the level of the water. You're looking to see. You're looking to see if it decreased, then it means that speed A is greater than speed B. If it increased, speed B is greater than speed A. So for this in the sake of our example, let's look at what happened. So the communicating vessel solution works as well. Let us use our Scrooge versus Burns example. There are two vessels, each in a separate secret space belonging to Scrooge and Mr. Burns. So Scrooge's vessel A is connected to Mr. Burns' vessel B via a underwater pipe. There is water in both vessels. Mr. Scrooge is pumping water out of his vessel at a speed of 8 gallons per second, while Mr. Burns pumps water out of his vessel at B gallons per second. So, but how does that help? How is that helping? How is that? How does that help us? How is that relevant to this problem? Well, the communicating vessel solution continues like that. In this solution, you would look at the level of the water. The level of the water is affected. So if the water descends, that means that A is greater than B. Otherwise, if the water increases, then A is less than B. So for the sake of our example, assume that their individual speeds are their well. Now assume that the water level descended. That means that Scrooge is richer or wealthier than Mr. Now for the public key encryption, public key encryption is basically what we've learned in class so far. So what happens is this is an encryption decryption mechanism or tool that uses two keys for encryption and decryption. So the public key will encrypt, the private key will decrypt. And the way it works in JAWS Millionaires problems is as follows. You would take, so person A and person B. Person B would take his public key and he would encrypt his wealth. To the encrypted wealth, he would add his wealth again, plus 1. And he would send this to person A. Person A will then, to this encryption, will then add her portion, minus 1. And would take it, minus 1. Person B will do minus 1, person A will do plus 1. And we'll send it back to person B. Person B will then decrypt the encrypted code, and if he sees that there was one added to his wealth, then he knows that he is richer than person A. But if there was no one added to his wealth, then person A is richer than he is. Now, I didn't see, so the public encryption is an encryption technique that uses different keys for encryption and decryption, providing a secure communication between two parties. It is secure because you share the public key, but you do not share the private key. So public key is for encryption, private key is our RSA crypto system from class. And the reason why it's not as I was trying to implement this in a program, and I had the program compile. The problem is when I run it, it didn't actually do what I wanted it to do. So I didn't add it to the project, but I would really love to put it in the project, but it wasn't working. It wasn't doing what I needed. It wasn't showing me what I needed to see, and I just didn't feel like I could put it in the project. So I do apologize about that. I've learned a lot in this project. I mean, there's so many tools, so many encryption tools, so many decryption tools. I mean, it's incredible. I never thought that I would see so many encryption tools and decryption tools. So many cryptographic tools. It is incredible. It is my first time taking a cryptographic class. Um, and I learned a lot. I mean, it's just things that you use every day have all of these tools and mechanisms to prevent, to keep everyone's information safe and secure. That, I mean, you don't think about it until you actually take a class. I mean, you know that they exist, but you don't actually think about the effect that they have until you actually take a class until you actually take the class that explains it a little better to you. So I really did learn a lot. And that will thank you. I hope you enjoyed my presentation. These are my references. Um, yeah.